Okay, so power. What's power? Power, by definition, is basically the rate of work done with respect to time. That's what power is. Power is basically work done with respect to time. Okay, now what's the formula? If power is work done with respect to time, then what is the formula? Well, let's find out. Work done upon time. That's the formula for power. So power is simply equal to work done upon time. And remember that power is a scalar quantity. Okay, it's a scalar quantity. It's not a vector quantity, it's a scalar quantity. Yeah. Acha, there's another formula of power that we must have seen, and that is force into velocity. Now, the question is, where does that formula come from? So here's where the formula comes from. It's not rocket science. Work done, as we know, is force into distance. Okay, so work done, as we know, is force into distance and divide by time. So what is distance upon time? Well, distance upon time, if you think about it, is velocity. So therefore, power is equals to force times velocity. And remember that whenever we are talking about power, okay, so there's an important note which I'm going to make you guys write down. That is, the force is always the driving force. Okay, so power किसमें होती है? Power होती है engine में. ठीक है, power normally आपके एक engine में होती है. It's an engine that develops power. Or maybe if let's say you're pedaling a bike, there that is when you have powers. Okay, so we're talking about the driving force. So in the formula of power, F is always the driving force. Okay, so I want you guys to keep that in mind at all times, that the formula of power has driving force into velocity. Okay. This formula is valid when the object is in constant speed. This formula, we'll talk about that. We'll talk about that. So it's basically at an instant that we will be talking about. Okay, so we might have to find out the velocity at a certain instant. Okay, now power remains, the power that an engine produces remains constant. You'll find it out. You'll find out in the question. Question will say that the engine is producing a certain power constantly, or the power is constant, so and so. So, well, when we get to questions, you guys will find out. Okay. Achha. Another important key point is that remember power is produced by an engine. Okay, so that means whenever you have questions related to car, maybe, or maybe there's a truck, or maybe there's a lorry, okay, that is when you will have power. Okay, and make sure to read the question carefully. It will mention what the power is and the fact that it's constant. Okay. Now, another important key point is sometimes the question will ask you for the maximum velocity or the maximum speed. Okay, so maximum speed, which basically results in maximum power. Okay, so if you think about it, imagine that the driving force is constant. The maximum speed will result in maximum power. So another important note, here it is. Maximum power results in maximum speed, and maximum speed means zero acceleration, and therefore net force or resultant force will be zero as well. Okay, so this will make more sense when we are solving a question, but for now, remember this: the driving force minus the resistive force equals to mass times acceleration. And if the object is traveling at a constant or maximum speed, that means acceleration is equal to zero, and the driving force minus the resistive force is equals to zero. Okay, when we get to a question, we'll talk about that. Okay, long story short, it's the net force which is equal to zero. Okay, now let's do some very simple questions, very simple questions, and let's understand how the concept of power works. Okay, so these are not questions from the book, so not from past papers, so don't start panicking. I can't immediately take you guys to past paper questions, but we will do past paper questions in today's class, inshallah. So here's a question. A car is pulled up a slope at a constant speed of 8 meters per second by a force of magnitude 1500 newtons acting parallel to the motion of the car. Find the power, giving your answer in kilowatt. Achha, one thing I forgot to mention is that the unit of power is watt. Okay, as in it's not watt, it's W-A-T-T. Why? Because it's joules upon seconds. So that is basically equal to watt. Okay, and kilo basically means 1000. So keep that in mind. Now, A very simple question. Let's solve this. Let's see what we can do over here. Power, as we know, is equals to force times velocity. But remember, it's the driving force times velocity. So what is the power? The power is 1500. What's the velocity? The velocity or the speed is 8. So that means it's 1500 multiplied by 8. But here's the thing. We're supposed to give our answer in kilowatts. So we'll divide it by 1000. So that means the power is equals to 12 kilowatt. Okay, very simple. Now let's do another question. This is example number 2, a question related to maximum power. A car moves along a straight horizontal road against a resistance of 800 newtons. Okay. The maximum power of the engine's car is 10 kilowatt. Find the maximum speed of the car. Okay. Yeah, sure. I can do that. There you go, Bilal. Let me know when you're done. Okay. So let's solve this question. Now remember, the rule is that it's the driving force minus the resistive force, which is equal to the net force. Okay. Now, reason why I'm saying driving force, because there is no other force over here at the moment. Okay. Now, how do we find out the driving force? We know that power is equals to force times velocity. Now, what's the power? The power is 1000, 10,000 actually, because it's 10 kilowatt. What's the driving force? We don't know. Okay. And what is the velocity? We don't know that either. So if I find out the driving force, that would be equal to 10,000 upon velocity. Okay, so this is a force, but remember, this is the driving force. Why? Because we have made F from the formula of power the subject, so therefore we will get the driving force. So the driving force, which is 10,000 upon V, minus the resistive force, which is equal to 800 newtons, is equal to what? Is equals to mass times acceleration, the net force. Now, because it's moving at a maximum speed, okay, because the speed is maximum, that means the point where it reaches the maximum speed and it continues to move at that speed for a while, then the acceleration would be equal to what? The acceleration would be equal to 0. So that means 10,000 upon V minus 800 is equals to 0. So all you have to do now is solve this equation. And when you solve this, and given that you solve it correctly, you get 12.5 meters per second. Okay. So these were some very basic questions just so that we can, familiarize ourselves with how the formula is used. Now we're going to do some tricky ones as well. So if you have any questions so far, please let me know. Although I doubt you have any questions so far, but still, if you do, let me know. And now we're going to solve some tricky questions. Some lengthy ones. Okay, not tricky, lengthy. It's just, remember, whenever you're dealing with power, it's just one extra formula that you have to deal with. Okay, so the main issue that students have is with work energy principle. Power एक काफी simple सा concept है, उसमें ज़्यादा students को problem नहीं होती. Okay. So, like I said, I've taken out some questions. Let's start with some easy ones and then increase the difficulty level gradually. Here it is. Now, I think you guys can also solve this question because it's very simple. Oops. Here. A crate of mass 800 kg is lifted vertically at constant speed. Okay, very important. By the cable of the crane. So that means the driving force here is the tension. Find the tension in the cable. Okay, so how do I find out the tension? Any idea? See if you guys can figure it out. It's a 1 mark question. It's very easy. What would be the tension? If you're lifting an object which weighs 800 kg and you're lifting it at a constant speed, so what would be the tension equal to? That's correct. So tension would be equal to the weight. Okay, so T And what's the weight? The weight will be 8,000 Newtons. So T minus W is equals to mass times acceleration. So T minus W equals to 0. Therefore, T is equals to W. And therefore, T is equals to 8,000 Newtons. Okay, no big deal. Now, I hope this is clear to everyone. Now, part two. The power applied to the crate in increasing the height by 20 meters in 50 seconds. Okay, so what's power equal to? Power is equals to force times velocity. Can we use this formula? Well, not really, but the formula that we can use is this. Work done into work done upon time. Okay, now what about the work done? If you're lifting an object and you're lifted by 20 meters, that means the work is done against gravity. Okay, so the work that is done is basically the work that is done against gravity. So the work done against gravity, which is equal to the potential energy, that would be equal to mgh. Now, mg, that's the weight, which is equal to 8,000. Okay, multiplied by the height, which is equal to 20. So that's equal to what? That's equal to 160,000. So we have the work done, which is 160,000. We divided by the time, that's equal to 50. And what's that? Let's see, what do we get? 160,000 divided by 50. So we get 3,200 watt or 3.2 kilowatt. ठीक है, अब इसको करने का एक alternative method भी है. There, you can do this another way also. As in, it's the same formula. Sorry, it's the same working, the same values, but the formula is slightly different. So alternatively, here's what you could do. We know that power is equal to work done upon time. Okay, and what's work done equal to? Work done is equals to force times distance upon time. Now, what's the force? The force is the tension. And what's that equal to? That's equal to 8,000 since you guys just worked it out. What's the distance? The distance that it moves is 20. So we multiply that by 20. And what do we divide it with? We divide it by the time. So you end up with the exact same thing. And which is why you end up with the exact same answer as well. 3,200 watt or 3.2 kilowatt. Okay, so fairly easy question, but still, if you guys have any questions, please let me know. Yeah. Okay, now let's do another question, a slightly more complex one. And please remember, I'm going to keep on mentioning this again and again, that when we're dealing with power, it's just one extra formula that we have to deal with. Okay, and what's that? That's power equals to force into velocity or work done upon time, one of the two. So here is the second question. A car of mass 1200 kg travels along a horizontal straight road. The power of the car's engine is 20 kilowatt. The resistance to the car's motion is 400 newtons. Okay, so the power of the car's engine is 20 kilowatts. Okay, so this does not mean that the power that it's producing, this is the power that the engine has. Okay. The resistance to the car's motion is 400. Find the speed of the car at the instant when the acceleration is 0.5 meter per second squared. Okay. So how can I find out the speed? Remember, power is equals to what? Power is equals to force times velocity. Okay, now what's the power equal to? The power is equals to 20 kilowatts. So that means 20,000 is equals to force times velocity. And why am I using this formula? Because I know that the driving force minus the resistive force is equals to mass times acceleration. Okay, so while I have the resistive force, I have the mass and acceleration, I don't have the driving force. Now, what's the driving force equal to? The driving force would be equal to 20,000 upon the velocity. Now let's plug in this driving force over here. So 20,000 upon the velocity minus the resistive force, which is constant and it's 400, equals to mass times acceleration. That means 1200 times 0.5. And all you have to do now is solve this. So let's solve this step by step. 20,000 upon V. 1200 into 0.5 is 600. 600 plus 400 is 1000. So we can cross out the zeros and velocity is equals to what? Velocity is equals to 20 meters per second. Now, as always, take a good look at it. Let me know if there is any question. Okay. Now part 2. Part 2 says show that the maximum possible speed. So you'll find questions like these often. Remember, whenever the question says maximum possible speed, that means the driving force equals to the resistive force. Why? Because acceleration is equal to 0. So now, once again, we're using the same formula, driving force minus resistive force equals to mass times acceleration. And the driving force remains the same. It's 20,000 upon V. Okay, minus the resistive force, which is also the same, equals to mass times acceleration, which is going to be equal to 0. And now we're supposed to show that the maximum possible speed is 50. So 20,000 upon V is equals to 400. You can simplify before you cross multiply. So V is equals to 200 upon 4, which is 50 meters per second. Okay, so there you go. That's the answer to part 2. Also a 2-mark question. So the first part was 4-mark question. I think 4 easy marks. This was also, I think, an easy question. Now let's do part 3. Part 3 says that the work done by the car's engine as the car travels from point A to point B is 1500 kilojoules. Okay. Given that the car is traveling at its maximum possible speed, so what's the maximum possible speed? That's 50. Between A and B, find the time taken to travel from A to B. Okay. So let's see what we can do. So what's distance equal to? Distance is basically equal to, so if we talk about work done is equals to force times distance. Okay. Acha. Up, according to the question, the work done is 1500 kilojoules. That would be 1500 into 1000. Sorry, 1500 into 1000. So 1500 into 1000 means 1,500,000. Okay, and what's that equal to? That's equal to force times distance. Now, what's the driving force? We can find out the driving force. Why? Because the question says that it's traveling at its maximum possible velocity. So that means the driving force, which was earlier 20,000 upon V, will now be 20,000 upon 50 multiplied by the distance. And what distance are we talking about? We're talking about the distance from A to B. Okay, so I repeat. Since we know the speed at which the car is traveling, that means we know what the driving force is. The driving force is equal to 20,000 upon 50. Okay, so 20,000 upon 50, that's the driving force. We know the work done, and work done is equals to force times distance. So that means we can find out the distance as well. So let's find out the distance. Let's see what we get. So the distance would be equal to 15. How many zeros? 5 zeros. 1, 2, 3, 4, 5 into 50 divided by 20,000. Okay, so we get the distance, and that's equal to 3750 meters. Okay, that's equal to 3750 meters. Why meters? Because the velocity was in meters per second. Now, what are we supposed to find out? We're supposed to find out the time taken to travel from A to B. Now, because it's the speed is constant, so we can use the formula where we say time is equals to distance upon speed, and the distance is 3750 upon the speed. And what's that equal to? That's equal to 50. So let's work it out. 3750 divided by 50, that's equal to 75 seconds. And that's the answer. Now, as always, take a good look at it. Let me know if you have any questions. Okay, so I'm going to give you guys a question to solve. And here it is. Solve this question. I will give you guys, since it's a 3 and 3. So for the first part, I'll give you 4 minutes. And for the next part also, I'll give you 4 minutes. But when you have the answer to the first part, do share it with me. Okay, 600 is the correct answer. Good job. Now I want you guys, just in time, I want you guys to do part 2. So I'll give you the same amount of time for part 2 as well. Given that the car has a mass of 1200 kg, find its acceleration at the instant when its speed is 20 meters per second. Okay, so at the instant means if I want to find out the acceleration, I'll have to use Newton's second law, which is driving force minus the resistive force equals to mass times acceleration. Now, you guys have already figured out the resistive force, which was what, 600, 400? Kya tha? Let me double check. 600. Okay. Now, how do I find out the driving force? Notice that the power is 18 kilowatt. Okay, so power is equals to force upon velocity. So if the power is, sorry, force into velocity, not force upon velocity. So if the power is 18 kilowatt, that means 18,000, and that's equal to force times velocity. That means we can find out the driving force. So how will I find out the driving force? I'll take 18,000 divided by 20. So we have 900 newtons, which is the driving force. So that's 900 minus the resistive force, which you guys have already worked out in the previous part, equals to mass times acceleration. So acceleration is equals to 900 minus 600 divided by 1200. So that's equal to 0.25 meter per second square. There you go. Okay, so I hope it's now clear. Now I'd like you guys to do part 1 of the 4th question and then part 2. Now I know part 2 is lengthy and I really want to solve part 2 because we will be using the work energy principle. But I'd like you guys to first do the first part and then I'll give you guys some time to attempt the second part as well. But if not, we'll solve it together. So go ahead. Says that a car of mass 1200 kg travels along a horizontal straight road. The power provided by the car's engine is constant. Okay, so that means no matter the velocity, no matter the. All right, no worries. You can hold on and see what the correct answer is. Okay, so the power is constant. So that means no matter the velocity, no matter the force, the power remains at constant at 20 kilowatt. The resistance to car's motion is constant, so that's also constant and is equal to 500 newtons. The car passes through the points A and B with speeds 10 and 25 meters per second. The car takes 30.5 seconds to travel from A to B. Find the acceleration of the car. Okay, so how do we find out the acceleration? We need Newton's second law, which is driving force minus the resistive force, which is equal to mass times acceleration. Now, how do we calculate the driving force? Now, remember, we want the car's acceleration at A. So that would be 20,000. Okay, 20,000. No, not 20. Yeah, 20,000. I've written 2,000 and I'm saying 20,000. So 20,000 is the power, which is equal to force times velocity. So the velocity that we're going to take will be the velocity at A, which is 10. So that means the force, the driving force, is equal to 2,000 newtons. So we have the driving force, 2,000 newton minus the resistive force, which is 500, is equals to 1,200, which is the mass times A, which is acceleration. And then you can solve this, and most of you have done it correctly, and that's 1.25 meter per second square. Okay, no biggie. Now part 2. Part 2 says, by considering work and energy, find the distance AB. All right, so 8 marks, but trust me, 8 easy marks if you get the formula right. The formula is total work done is equals to change in potential energy plus change in kinetic energy. Okay, now remember, this is a horizontal straight road. So that means there will be no change in potential energy. Change in potential energy occurs when it's an inclined plane or a declined plane. So total work done would be work done by the driving force minus the work done by the resistive force. Okay, so we need to subtract the two. Now, what would be the total work done by the driving force as the car moves from A to B? The total work done by the driving force would be equal to the force multiplied by the distance. Okay, so what's the force? The force is 2,000. Okay, so we'll multiply that by the distance. And what's the distance? We don't know that. So we're just going to call that X for a minute. Okay, so that's the total work done. Minus the resistive force. So what would be the work done by the resistive force? The resistive force is 500. So 500 multiplied by the distance. Okay, so work done is force into distance. Keep that in mind. Okay. Now, this is equal to the change in kinetic energy. Now, how do we find out the change in kinetic energy? It's going to be half into 5 into 1200. Okay, into V square minus U square. So V square would be 25 squared minus U square. That would be 10 squared. Okay. So let's find out. Let's find out the. Acha, wait a minute. Sorry, I just realized I made a problem. It says the car takes 30.5 seconds to travel from A to B. So that means we will have to calculate the work done with the help of this. Just a minute. So X is the distance. X is the distance from A to B. So basically, I think I should have made a rough sketch of it here. Okay, so let's keep this intact. We're going to need this, but here's the thing. So basically, the car is moving from A to B. Now, what's the distance from A to B? We don't know. Okay, we don't know what that distance is. That's what I've called X. Okay. Now, what about the work done by the car's engine? Let's see if we can figure that out. Power, as we know, is equals to force into velocity, and power, as we know, the reason why we can't use this formula to find out the driving force is because the velocity is changing. So the velocity is changing. The velocity is different at A, the velocity is different at B. So that means I cannot use the driving force, the force into velocity formula to find out the driving force because the driving force must change. So instead, what I can do is I can use this formula. Power is equals to work done upon time. Okay, so why am I not using this formula? That's because the velocity is changing. Okay, so because the velocity is changing, I cannot use this formula. Therefore, in order to find out the work done by the driving force, this is the formula that I will use. Okay, so we're not using this formula, we're using this formula. So power, as we know, is constant. And what about the work done? We don't know. What about the time? How long does it take to travel from A to B? The time that it takes is 30.5. So that means this way, I immediately have the work done and I have the work done by the driving force. So what's that equal to? Let's work it out. So 20,000 into 30.5. So we have the work done by the driving force. Okay, so work done by the driving force is equals to 610,000 joules. All right, so now we're going to use this and we're going to plug it in this formula. So we're going to plug this in this formula right here. And where will this go? This is where it's going to go. The work done by the driving force is 610,000. Now, what about the work done by the resistive force? What's work done equal to? Work done is equals to force times distance. So the resistive force is 400. The distance is x. Okay. Now let's solve this. 610,000 minus 400x is equals to, let's find out the change in kinetic energy. So that's 0.5 into 1200 into 25 squared minus 10 squared. So this is equal to 315,000. Now 610,000 minus answer is equals to 295,000. So 400x is equals to 200 and, no wait, is it 400 or is it 500? Sorry, it's 500. Yeah, it's 500. Yeah. So 500x is equals to 295,000 and then find out the value of x. 295,000 divided by 500. So that's equal to 590 meters. Okay. So what's the key takeaway from this question? The key takeaway from this question is this, that if the velocity is constant, that means you can find out the driving force. Okay, you can find out the driving force, and that would be the driving force throughout, and you can use that driving force to find out the work done as well. But if the velocity is changing, and if the velocity is changing and the power is constant, that means consequently the driving force is also changing. So instead of finding out the driving force, what we can do is we can find out the work done by the driving force, because ultimately that's what we need, right? And we can find out the work done by driving force by using this formula. Power is equals to work done upon time. Okay, and when we use this formula, the work done that we get is basically the work done by the driving force only. Okay, so जब हम ये formula use करते हैं, the work done that we get is the work done by the driving force only. Okay, now let me see if we have achieved the target for today. Okay, so I found a question for you guys, and I'd like you guys to solve it. It's fairly recent. It's October, November 2019. And here it is. So it has 3 parts in total. I'll attach all the 3 parts together. So here's the first part. Here, this would be the last question. Whoops. There you go. So I'll give you guys 2 minutes to do the first part. And when you're done, share your answer with me. And then do the following question. Okay, looks like we have some answers. Let's check. So the first part is a show question. There's nothing really to explain there. I mean, you guys don't want me to obviously give you the answer. It's right there. Now let's have a look at part 2. Just a minute. Yeah. So let's do part 1 as well while we're at it. Now, part 1 says, show that the resistance to the cyclist motion is 16 Newton let's read the question. A cyclist is travel along a straight horizontal road. The total mass of the cyclist and his bicycle is 80 kg. His power output is a constant 240 watts. The acceleration when he is traveling at 6 meters per second is 0.3. Show that the resistance to the cyclist's motion is 16 newtons. Now, as we know, power is equals to force into velocity. So the power at the instant when he is traveling at 6 meters per second is 240. Okay. And the force at that instant can be worked out. So that's going to be equal to 40 newtons. Now, 40 is the driving force minus the resistive force, which we don't know, is equals to mass times acceleration. That means 80 times 0.3. Now work this out and you will have the resistive force, which is probably equal to 16. Okay. Now let's do part 2. Part 2 says, find the steady speed that the cyclist can maintain if his power output and the resistance force are both unchanged. Okay. So if the power output is unchanged, so power is equals to force times velocity. The power is 240. What's the force? We don't know. What's the velocity? We don't know, but we can make force the subject and we can say force is equals to 240 upon V. And what force are we talking about? We're talking about the, the driving force. Okay. So steady speed means acceleration will be equal to 0. Okay, steady speed means that the acceleration will be equal to 0. Now, the driving force, as we know, is 240 upon V minus the resistive force, which is unchanged, and that remains 16 is equals to mass times acceleration. So that means it's going to be 0. So if you find out the value of V, yes, Isha, that's correct. That's going to be 15. So 240 divided by 16, which is equal to 15 meters per second. All right, so that's the answer to part 2. I should have done this here. Okay, so I hope that's clear. Now let's do part 3. Part 3 is the reason why I've chosen this question. So in part 3, all of a sudden, the hill has changed. In part 3, the hill is no more. The hill is no more, it's no more horizontal. In fact, it is now an inclined plane. Okay, the cyclist later ascends the straight hill at 3 degrees to the horizontal. His power output and the resistance to the force are both unchanged. Find his acceleration when he is traveling at a speed of 4 meters per second. Okay, so what do we need to find out? We need to find out his acceleration when he is traveling at a speed of 4 meters per second. Okay, now what happens when he is on an inclined hill? What happens when he's on an inclined hill? Well, the resistance to motion is constant, which is 16 newtons. But then there is another force which will now be acting in the direction opposite to which the cyclist is moving. Okay, we don't have to consider friction, obviously. Okay, and that force is the weight component. Okay, now the angle is 3 degrees and the cyclist's and the bicycle's mass combined is 80. So that means this would be 800 sine 30. Okay, so this would be the force that's acting in the opposite direction. Now we're not gonna use the formula driving force minus resistive force equals to mass times acceleration. We're gonna use forward minus backward equals to mass times acceleration. Now, what's the forward force? There's only one forward force, which is the driving force. And what's that driving force? We'll have to figure that out. He is traveling at 4 meters per second. So that means power is equals to force into velocity. The power is constant, that's 240. The force we don't know, but at the instant when he is traveling at 4 meters per second, the force is 60 newtons. Okay. So the forward force is 60. What about the forces acting in the opposite direction? That's 16 and the own weight component of the cyclist, which is 800 sine 30. Okay, and this is equal to mass times acceleration. That means this is equal to 80A. Yeah, the angle is 3. You're right. I think I was supposed to write 3 degrees and I've written 30. You're right. Thank you for pointing that out. It is, in fact, 3 degrees. So here also, it's going to be 3 degrees. Let me fix this once again. Okay, now, so work this out and you'll have the answer. So do this directly in your calculator. 60 minus 16 minus 800 sine 3. I need to change this also to 3. There you go. Divided by 80. So the answer is 0.0266. And that makes sense. Why? Because this is a cyclist. This is not a car. This is not a truck. It's a cyclist. And if you've ever had a chance to ride a bike uphill, you would know how difficult it is. Okay.